Hi, class. For weekly comments, at least from me, typically they tend to be rah rah, you're doing great, I love your work, and stuff like that. I apologize about the lateness, and that's that we've had greater problems and hours and everything else. The university is changing over its system, and there's been some growing pains. But anyway, it will catch up even if I have to grade it myself. Anyway, walking through this, first one, multiple choice questions, pretty much just prep you for the quiz that's coming up. And I think it's next week. The way the quiz works is I give you a window, meaning you have a couple of days, and you pick when you want to take it. Now, here's the catch though. If you are late, if you leave it to the last minute, you have computer problems or anything else, there's no forgiveness. You get a 0. And so be careful, leave yourself enough slack. I had one student, holy smokes, 60-minute quiz. He started at 11 p.m. for 11:59, and his computer broke down, and he started crying to me about it. One student was flying home to India, and he asked if it's okay if he flew instead of waiting here to take the quiz. I said, well, you're taking a risk here because, what if something goes wrong? He said, oh, no, I'm going to land 4 hours before I have to finish the quiz. So I got plenty of time. And I was there like, all right. Well, as it turns out, guess what? He got delayed in San Francisco. San Francisco is a tough city to connect through because they have fog problems. Anyway, he didn't get home until like 4 hours after the quiz was over. And anyway, it wasn't pleasant. Now, how many of you have seen the movie Gladiator? Yeah, a lot of you know the tale about Maximus and all. But here's a tale you probably didn't know. Maximus walked into a bar in Rome and he asked, I'd like to order some beers. The bartender said, how many? And the bartender said, 5 beers it is. Get it? Roman numerals? Anyway, okay, the first problem is fairly straightforward. There are examples in your book, there's examples in the lecture of what a work breakdown schedule looks like. So just pick a project. The big mistake people make is remember you have to number everything, and there has to be work packages associated with something. Now, this problem is just a network problem, and it shows you the predecessors, the successors, and everything else. So, how many pathways are there in this network? Well, I can go this way, I could go this way, and I could go this way. So all you have to do is add up the duration of every step, and then you know how long something is. Now, where do I get the duration? It's the middle number right here. So right here. And what is this number? The early start, the early finish, the late start, the late finish. Now, for those of you who watch the lecture, probably already know this, but for those of you who haven't, and yes, I know there are people who haven't, why? YouTube counts the number of times videos have been viewed. So I know a lot of you don't watch the videos, and that's okay. One thing about online is it really is a democracy. You have a choice whether you want to do things or not do things. The only thing I have to say, though, is if you don't take advantage of certain things, don't cry to me. Anyway, so the whole trick here is when you look at these boxes, this is a duration, this early start, early finish, late start, late finish. If there is no difference between the early start and the early finish, it means it has to be on the critical path. And what is a critical path? It's the longest length. Since it's the longest length, if I even change one day, then it changes the length of that entire pathway, which means it has no slack. The difference between these tells you how much slack you actually have. So in this case, 5 and 4, it means I have 1 day of slack. And so you could figure out what the critical path is in all these. And I will give you one little hint. What's 0 minus 0? 0. It's got no slack. Okay, that kind of makes sense. It's the first one. Second step, you have no alternative but to go to activity B. So 3 minus 3, slack is 0. What about F? And so 4 minus 4, and that tells you what you need to know. Now, you have to draw a new activity diagram. Instead of C and D being in series with each other, it tells you they now run in parallel. So if I drew this just like these two in parallel, I have to put C up here and D down here. And that's what my new machine looks like. Now activity F, it tells you buy a second machine. So we know this duration's 5, so now it's been halved. And now I need to recalculate all my pathways. And now I have an extra pathway because C and D are now in parallel. And so now I need to figure out what my new critical path is. That's all this question is. Now, this question is about using the risk factor equation. And I got a typo here, that should say RF. But anyway, calculate the overall risk factor, you know what the equation is, average all these, and compare that to what the low, moderate, or high number is. Now, what should they work on to get the risk down? And there's a couple of different ways you can look at this. When you pick the factors, first of all, look at, which number is, what makes this number so big? This is what I want you to do. Look at the numbers and understand what they actually mean. And so, is this the big number or is this the big number? Which is driving this number? The other thing to think about is, what do you have control over and what don't you have control over? That could be another factor. For example, look at all of these. Which of these do you have control over and which of these do you not have control over? Now this question, for those of you who noticed Jules and Vincent are the two characters from Pulp Fiction. Yeah, I'm a big Quentin Tarantino fan. I just love the energy. And you look at this and what the heck? We didn't go over this in class at all. Well, what I'm actually testing you on is your ability to use math. And so, when you look at this equation, what does I need to know? Well, I just need to know the probability, and I just need to know the consequence. If I know those, then I can figure out what the risk is. So, the one thing it tells you is that the probability is evenly distributed between 0 and 1. If I'm trying to do an estimate, and it's averaged out 0 to 1, what number are we talking about? The number in the middle, right? So, for example, for Jules' case, if it's a half, what's the consequence? Oh yeah, 0.4. He's the easy guy. In this one, well, you know what the line looks like, so you can just plug it in. And so you can compare those two. Now the second question, that's the hard one, because it's telling you that the range now is 0 to 60%. And what you're actually doing is it backwards. Here you use probability to get consequence. Now you have to start looking at what the average consequence happens in this. Now what's the average for this? Well, yeah, it's pretty straightforward. It's this one that's difficult. And to figure out the average, you actually need to know a little calculus. I don't expect you to know calculus. So guess what? I did the integral for you. B minus A is 1. The integral, what's our equation? 0.7 minus 0.7 times x. We integrate it, x squared over 2, so it's 0.35x squared plus 0.7x. And the x we're interested in is the extreme probability case, which is 0.6. So I plug in 0.6. Now when I calculate this, I now have CFs for both of these, but for PF, I need to use the middle of the range. So the middle of the range of 60% is 30%, 0.3. So plug the numbers in and then compare it again. And so what this problem is about is, first of all, rarely, because I've done a lot of work in risk management, do you ever get answers that are that primitive? And so you have to work on a more difficult answer. And they could be dependent on each other. And that's what this problem shows here.